So, in this video, I'm going to show you features that come with C# 8.0. This video is going to be about getting you familiarized with the new methodologies or the new terms in the C#. There are many new things in C# 8.0. I am currently listing all of the improvements, but in this video I'm not going to talk about all of them. I specifically chosen some things because I believe they might be more useful than the others. Synchronous ienumerable. Previously on C#, if you define an ienumerable method, you just return them one by one, but that system was not and cannot be done asynchronously. So each value you put out from the ienumerable depended on the next value, so you needed the whole ienumerables values to make something with them. But now, thanks to the asynchronous ienumerable, you don't need them. You don't need all of the ienumerables. You just process them value by value as they come. So it gives a very nice performance boost, especially in the IoT business sectors, I believe, but it's not limited there. It can be used anywhere, and it is guaranteed to make a performance boost in the code. And of course we are going to create a .NET Core project, because .NET Framework 4.8 not exactly supports the C# 8.0. And Microsoft said that it's fully supported in the .NET Core 3.0. So we are going to use that. Let's create a console application with .NET Core. Let's name it 8.0 tutorial. And here we go. This is our Visual Studio. And you know what? Let's get rid of this project for now. Let's remove this and add new project. Let's make the console application, and I think we should name this async streams. Should be good. Okay. What's new about C# 8.0 is async ienumerables, which helps us get the ienumerable projection with asynchronous style. First, I like to show you how the ienumerable works. So let's create a method. Take a little integer get numbers, and let's create a loop I0 to 10 and yield return I. Let's create a for each loop to loop through the iterate through the get numbers method. Numbers and let's run I. And I'm sorry about that. Item. Since this is going to immediately work because it's gonna work real fast, I'm going to add another thing here to act like this is actually taking time, not because it is. It's a task.delay, and let's give it a half a second. Okay, let's run this and see the output. As you can see, it immediately writes all of the results, but we don't want that. We want to enumerate them as they come. So that's why there is C# in the new version released asynchronous async enumerable. Let me show you this. Let's make this async enumerable. And if we do this, it means now we have to convert to this an async method. Let's make this async. Now we need an await, and just for the help, task.delay is asynchronous, so we can await that. Now for each loop gives us an error because it doesn't have an getEnumerator method. It does, however, have getAsyncEnumerator, and we achieve this, and we get this enumerator by writing await in the beginning of the for each. Now, of course, we have to, if we want to use the await, we have to make the method main is async, and we need to set the return type to task as well. Now, if we run this, as you can see, the numbers are written as they come right now. That's the beauty of the async ienumerable. Now, I'm going to show you some link codes. As you know, in ienumerable types, you can use link, but it's not yet developed for the async ienumerable. But fortunately, there is some NuGet packet to help us. Now, let's go to Solution Explorer, right click on our project, and let's say Manage NuGet Packages. In that, let's go to Browse, and we write System Link Async. Okay, and we install this package developed by .NET Foundation and contributors. Now let's get back to program CS. Let's assign this method to a variable var result equals get numbers. Okay, simple enough. But now if we want to apply some filtering or some other link function, now we can use var res equals result dot where, and let's add the package. Now we can use the link functions as well, just like ienumerable, but in an asynchronous fashion. Let's say we only want the even numbers. Let's go with that, shall we? And now if we iterate through this res variable, we should only get the even numbers. Let's run this program. As you can see, only even numbers. The program now gets the number, checks if it is, you know, odd or even, then prints it, then gets the next number. I mean, if the timing depends on the method and when it is going to give us the value. It can be any time because it is asynchronous now. There are some, however, some downsides of this. If you want to use any aggregate function of like reversing or summing, you need the whole list or whole array or whole enumerables to work through. So be careful about that. If you use any aggregate functions, like let's use, I don't know, sum, let's use sum. Now it's not something you can iterate through. Let's try something else. Well, what do we have? Reverse. Okay, now let's use reverse. Now we are waiting to fill the whole list. After the whole list is filled, now we write it all at once because we need the whole list. So be careful about the aggregate functions and use the beauty of the async enumerable. Interface members. Previously on C#, interface members cannot declare a body or can have access modifiers. Now both of them are possible because of C# 8.0. Now if we define a method in an interface, we can choose to give it a default body or none. If we choose to give a body, then we don't have to implement it to the implementing class. And you are going to see what I mean in the examples. If we want to add a new ID property to the interface, I need to implement it in the entity class. But if you create a default implementation of the newly generated ID method in the IID generator, I don't need to add it to every implementing class. As you can see the pictures on the right here, I don't need to implement the method necessarily because I already defined the body in the interface. Let's continue with creating another project. You're going to add new project, .NET Core application, console, and let's create default body. Let's start with creating an interface. Let's name this entity ID. Okay. Let's give this an GUID ID, shall we? Okay. Now, whichever class implements this interface must have an ID field. But I want to spark things a little bit. Let's create another interface. Let's name iGenerate ID, which implements iEntity ID. Let's create this, and I want to create a method. Let's say generate ID. Usually, in the old versions, this was the end. Now you create your class and implement this interface. But now we can do this. Create a body here. Let's say ID equals GUID dot new GUID. And now let's create a new class. Let's call this person and make it implement the generate ID interface and implement the interface. Notice that we didn't have to implement the generate ID method because it already has a body member, and we can use this body member from the class person. Let's prove this by coming here. Let's create some new person object. Now, in this person object, we can access the ID field defined here, but as you can see, we don't see the generate ID method. That's because we define this variable as the person class, and that's why we don't have the generate ID method here. But we write it there, we have to access it. So what should we do? Now, what we do is simple. Let's create another person object and I'll show you. But let's define the object this time as iGenerate ID interface member. So person G equals new person. Now person G has the ID field and the generate ID method. We can use this and it will of course trigger this method. But there's also one more problem here. If we had another property here, let's say string name, we cannot access it from person G dot name. Of course will not appear here, however it will appear in the person class, and we can overcome this by casting, of course, and it's the most valid solution we got right now. So I suggest you use that. If you want to access the name field, you just write person.name, and if you want to access the method, just come here and use this and use the method. With these implementations, there are also some other changes, like this one. Now we can define private and protected and other accessibility members to our methods and properties. And counter, and of course it has to be property. Now it's giving us an error because it does not have a default body implementation, so it is going to give us an error. If we were to write a body for get and set, it will stop giving us an error, of course. Now what can we do with this? I don't know. And maybe just oops, sorry about that. Let's see, maybe something, I don't know, 5. Let's try 5 and use another variable here, use the counter, and now we have a private field. Like this, C# 80 gives us many things, and I hope we can use it all correctly. Let's see what happens when we add the method to the person class. We write public void generate id, and let's say name equals something something. This method inside the person class will override the generate id method in the interface because it's a default implementation, and right now we are defining something else. Let's go at this breakpoint here and change the startup project to the default body and run this application. As you can see, breakpoint hits in the person class generate id method and do something with the name property. Generate id method in the person class or any other method, doesn't matter, will override anything defined in the interface. Indices and ranges. This new technique is not an especially improvement, but it helps us to usage of the arrays and accessing indexes and accessing specified points of the arrays make it much more easier than before. And we are going to make an example of this, but for now you can just look at the table here and see the difference it does make. Now we can get into indices and ranges. We start by open up our solution explorer and adding a new project to our solution. Let's choose a console application. I say indices. By this feature, now you can access your indices and ranges a lot more easily you would have done it in the previous C# versions. Let me show you how this works. Let's create a new int array and let's fill this with random numbers. Previously, if you wanted to get the last element of this array, you have to do something like this. Get the length of the array and subtract 1 and you get the last in the index of that element. But now simply you can do this. You put a circumflex and 1. What this does is start counting from the length of the array to the 0. So when we say circumflex 1, it means actually 0, 1, 2, 3, 4, 5, 6. It means 6. This expression is equal to this expression, and we say second last and circumflex 2, it will be equal to fifth element, and it is 6 in this case. And we can debug this and see the results firsthand. Let's choose the startup application as the indices project and press F5 to run it. As you can see, our last element in this case is 7, and in this case it is also 7 because expressions are the same, and the second last element is 6. Now ranges. Ranges can be useful, and depending on the situation. Let's say you want to get second through the fifth index, so we say range plus r dot 5. It is going to give us this, including the second index to the fifth index, but the 5 is not included, so keep that in mind. As you can see, 3, 4, 5, and the second index is 3, and between them there is 4 and 5, and the fifth index is 6, but remember, the last number we write here is the excluded part, and the first one is included. Now if you want to make something make different, you want to take we don't want to limit ourselves with 5, we want to take all the ones since 2. We write this. Now it is going to give us all the elements starting with the second index. Let's run this and see. As you can see, started with the second index, and we get all of them. If you want to say get the second last element and the ones after that, we simply add a circumflex here, and it should take what we desire. We look at ranged values, and you can see 6 and 7, because we take the second element from the end, which is 6, and to the end, and that's 6 and 7. Now if you want to say take the before this last second element, I think we can do something like this. Actually we can't do something like this, but we can do something like this, I assume. Here we go. 1, 2, 3, 4, 5. We excluded the last 2 indexes. Now ranges. These expressions right here are called ranges, and we can put them in a variable, a range variable actually. We say range equals this one, and if you write range here, it should also do the same work as well. You can see same output as before. Let's stop this one, and if you want to say take the second last element to the beginning until you see the second index, it should be done like this. As you can see, 3, 4, 5. Now there are many things you can do with the indices and ranges if you make it properly, of course. Null coalescing assignment. Actually, this one is also not that much of an improvement, but I like the way it saves the code from unnecessary nesting with an if statement. What it does is assigns a value if that variable is currently null. I like to show you a little something. It's not about indices and ranges, but something might be probably useful. Let's say you have a string ast, I'll leave that empty. We call this null coalescence, and it can be useful. St equals something. Now, as you can see, it's simple. We just create a variable named ASD and we make it equal to something. But after we create the variable, it's actually null. And it might not be null depending on some if condition here. Now, there might be some random condition which takes the ASD and fills it or may not fill it. And after that, you don't know if ASD is empty or not. Now you can simply check ASD equals null, then take this and make it equal to something else. But now I'd like to talk about something else. This expression is fully correct, of course. It's given an error because it's not assigned before using it. So if we do this, oh, I'm sorry about that. Now it stops giving an error. And it's fully correct to do something like this, but thanks to C#8 it became simpler. Now we can just write this ASD question mark equals something. What this does is, if ASD is null, then it takes the string and puts it into the ASD. And if it's not null, this line does nothing. If it's null, make it equal to string text. Now with this completed, we can now get to the nullable reference type.